Exercise SetA question 1. The gist or summary of this problem is that there are two events and we are required to find their joint probability distribution. These two events are the direction of the market has a probability of the 60% and a signal that these three type of investor use to take a long or short position in the market. And we are meant to fill a table like this to show the joint probability distribution of these two events. For example, in this cell, it means that the market is down and the signal is also down. This cell means that the market is up and the signal is also up, and etc. Now let's do the part A. Investor A throws a coin which is biased to show head 70% of the times. That his probability of head is 70%. Whenever coin lands on head, he takes a long position, otherwise short position. All that sentence is translated to this fact that the probability of the signal being up is 70%. So, fill the above mentioned table. Let's go to the solution manual. Okay. Now we are supposed to fill in this table. The important point is that we realize and notice that these two events are independent. Therefore, the probability of their joint distribution is the product of its separate probability. For example, here to fill in this cell, the probability that market is up and signal is up, we simply multiply each separate probability together and we obtain 42%. As another example, we can do this, for example, part probability that market is down and also signal is down. It's 40% by 30%, which is 12%, and etc. Okay, now going to part A2. Given the market is up, what is the probability that a long signal is generated? That is, we are after this conditional probability. Here, we can go to this hint part and this reminder that if two probabilities are independent, this relationship holds. So, here we can say, again, by using independence, this relationship holds, and the probability that we receive an up signal given market is up is the same as always the unconditional probability of receiving an up signal. That is, regardless of the direction of the market, the signal always generates a lying position with probability 70%. Now to part A3. Given a lying signal is generated, that is, this investor has thrown his coin and has received a head, which means lying. What is the probability that market goes up? That is, the probability of market is up given we have received an up signal. Okay. So again, using independence property, as noted in the reminder in the hint part, the probability that the market is up given we have received an up signal here is simply the unconditional probability or marginal probability of market being up, which is 60% as given in the question. Now going to part A4, what is the probability that the signal is correct? Here, simply correct means we have the same value for both market and signal. This translates to this form of, this is all same probability statement. We are looking for this sort of probability that market is up and signal is up, or market is down and signal is down. Now going to the solution manual, which explains the probability of being right is equivalent to probability of both market and signal generate the same value. Okay, here there are only two states. Therefore, either both market and signal have up value or both have down value. So, the important thing to notice here is that these two probability or these two events, this can be some event that market is up and signal is up, and another event is market is down and signal is down. These two events are called in the probability theory disjoint events. The disjoint events have no common or they don't have any intersection with each other. And to obtain this probability, we simply add each separate probability together. Okay, so using information from the contingency table, we need to use the information from part A. Here, we need to use this information we obtained earlier. We get this result that probability of market up and signal up, or market down and signal down, is 12%. This is the market down, signal down, and this is the market up and signal up. 12% plus 42%, which is equal to 54%. Well, it's interesting, this guy uses some coin and gets an accuracy of 54%. This is the end of part A of the question 1 in exercise set A. Now part B. Investor B only takes a line position, that is probability of the signal being up is 1 and the probability of the signal being down is 0. So fill the above mentioned table. What is the probability that the signal is correct? Well, going to the solution manual. The logic to solve this part is exactly as the logic of the previous part, part A, with this difference that we receive a down signal is 0. So using the same method, we obtain this table. That is the probability of market being up, and the signal is always up, so their joint probability will be 60%. And note that any event that contains the signal being down is 0. And for the next part, we are required to calculate this probability, which is similar to the previous part. And using that method, we obtain that the probability that this person is right is 60%. This is the end of part B of question 1, exercise set A. Now to part C. In this part, investor uses some sort of page signal to take a long or short position. The main difference with the previous two parts is that now the signal movement and the market are dependent through this conditional probability distribution. However, the unconditional probability of the signal is 40%. That is, 40% of the signal that this investor receives says take a long position. And we are asked to fill the above mentioned table and what is the probability that the signal is correct. So going to the solution manual. The main difference here is that since these two events are sort of dependent with each other, we can't just simply multiply their unconditional probability. To calculate the joint probability, we need to use this conditional probability formula, which says that we need to multiply this part, which says the probability of market being up given the signal is up, by this part, which is the unconditional part of this formula that says the probability of the signal being up. So this is given in the solution statement. This is also given in the problem statement, and multiplying these two yields the joint probability of the market being up and signal being up. This is for this cell of this table. To fill the rest of this table, we need to use this relationship that, of course, it is given in the problem statement. And note that the probability that market is being up, if we want to calculate this from this joint probability, is the probability that market is up and signal is up plus the probability that market is up and signal is down. Anyhow, in this table, the sum of these two will be this one. Okay, so we simply subtract 30% from this 40% and we obtain 10%. Again, the sum of these two parts should be equal to the probability that market is done. The probability that market is done is 40%, which if we subtract 10% from 40%, it yields 30%. And similarly, here the probability that signal is done is 60%. So if we subtract 60% from this 30%, we should obtain 30%. And as I explained before, all these calculation is based on this property that the marginal and joint distribution have with each other. And for the final part, we are required to calculate the probability that this person is right, which is of the form of these two disjoint events. And similar to previous part, if we just plug in these numbers from the table, we obtain that this person is right 60% of time. This is the end of part C of the question 1, exercise set A.